Hello and welcome to episode 2 of Code Deep Dive with OpenTTD. Last time we got familiar with how the project is organized, and we just ran the main routine and just figure out what are the config paths for OpenTTD and how they're managed and how they're parsed. And I think the finishing thing was scanning some tar archive that are storing some assets. So we'll start from that. I think the missing piece in last episode was that I was not able to output the debug content. So I hope I have fixed that, and we should also see some things in the terminal now. So when I run the code, it's actually here some debug string. Okay. Yep. So what I'm doing now is I'm passing the D option. So last time I didn't pass anything, so we didn't really get into this while loop. So now there is option D, and because it's not really empty, I'm just setting some value 9. There is the set debug string value passed in, and if we see here, what happened is that this is just some level number, and the bigger the level, the more detailed debug messages are. So there's something that's called string consumer. It should be here and there in the code, and basically it just helps parsing the numbers and just constructing or just reorganizing the string values. So in this case, we just assume there is some 10 base integer, and we will just try to do something with this. So there's just some parse integer base. Let's see what's that. Okay, so substring from the position. Okay. Yeah, so base 0, it's probably 10 here. So not really. We only this. Okay, so there's support of various bases, and then this will just return. What's that? From characters. Value 9. Okay. Okay. Oh, okay. So just probably in this case it just returns. Hold on. Result type. Okay. Okay. I'm totally honest. I don't know what it is, but it actually parses the length of the string. So we just have left and value. Okay, where was the value here? Oh, all right. So we have our source data here of the given length, and then this just uses from characters to just parse this integer value and returns the amount of the pointer, actually, in this case, to the last parsed character. So or actually, yeah, to the 0, terminating 0 value. Okay, nice. So we have a par. So we know that there was value of 9 and the length of 1. Like the string value was 1. Sorry, the string length was 1. Okay, and then what is that? Skip integer base. Skip if. Yeah, skip if, big if. Okay, so we're still in string consumer. So this is like a utility class. So there will be a lot of such functions, I guess. So if big if, what is big if? Oh, it's just compare. And we just compare that okay, why is it hyphen here? Check whether next data matches string. Does it? Okay, then skip. Okay, so it checks if the next character or next substring maybe even is at the given position is equal to the attribute, and then if so, it skips. So it's like a conditional skip. That makes sense. So maybe yeah, but why hyphen? I'm not really sure, but maybe it was later. Okay, and then for base 10, skip until character not in. Okay, so it assumes that there might be some other characters. Okay, find character not in. Yeah. Substring at this position. Find first node of cars. Right. Okay, so this is actually string view. Okay, it found really big value. Okay, so it returns end position, which is in this case just indicating that it didn't find what was what was looked up. So it just scans till the end of the string, and there's nothing more left to be searched for. So here, I think what's important in the string consumer class is that there's a position attribute which just tells at which position simply we analyze the input string. So we just check if there's anything more left for the integer number, and since there is nothing, then maybe we just continue. Okay. Okay, and here, since we have some level, and I put 9, I'm not sure if this is like a maximum number, but this I saw number 5 somewhere in the logs, and I think even 6, so I just want to make sure that we log as much as possible. So here we have levels, which is the map here. So for each level, there is something like the bug levels, and this is, okay, list of something like this. So there are some categories of debugging levels, probably, and it's just possible to set up some of these. In this case, we just set up for each of these, we just set up the same level, which is 9, and you see it's like driver, console, script, whatever. Okay, we can skip to here. And then we still have this consumer, any bytes left. So here we have only 1 byte, so probably not. And then apply the changes after parse is successful. Okay. New levels, find So this is our map here. And then until it's not there. So why is it different from this? Okay, debug level. Okay, it seems like you just copy things back and forth, but I guess this is because if there are some individual levels here, which is not the case, then probably we can just override some. And so initially we just copy everything, like initialize every debug level with one number, and just in case it's overridden in the setup for particular level, we just update that, and then the global debug levels are just changed. Okay. Okay, back to the do scan. Okay, you haven't seen that, but it took a lot of time to load this enum bit set for whatever reason. I'm not really sure. So the reason why we are here is because this do scan accepts scanner modes, and these modes are just this bit set. And I think here we are just scanning for the base sets, which is reference to the config path we saw in the previous episode. So here we have debug, and can I show that? I hope I can. I'm not really sure, to be honest. Let's see. Oh well, maybe that's faster pink. Okay, I was pretty sure there's a debug print somewhere here. Okay, yeah, let's print that. Here we go. So basically, when this debug is called, we have a couple of things here. So we have the message, and we have level, and this is the category. And what's happening here is that it just evaluates to this debug print, which is just a format print of this kind of messages. So here we can see the examples, and so scanning for tars in this we have the category here and the level of the debug message. And this suggests some remote console, but we don't really have. And we are back to the scanning. So what happens with the scanning is that this is some static function, and there's the tar scanner, and then we can test against this enum set, enum bit set actually, and we just look it up if there's the base set. So convenient way to just bit set different kind of sets here. And if this was enabled, which is the case, there's the do scan, and we have the subdirectory, so base set, and then here are some global variables that may be important. So there's tar file list, which is basically map of strings and the entries. So basically, I think this is just the name of the tar file, and here there's just the entry of. No, that doesn't make sense. So probably the name of the entry in the tar file. Maybe that makes more sense. Okay, let's see how it goes. So we are just clearing these, and then there is a scanning of this directory for tar files, which I think we saw last time. And so basically just scanning the paths, all the white ones, and if we find anything, then the files are somewhere here added. So yeah, I think this was something that we were interested last time. Oh, okay, debug again. I will just skip that. Okay, so scanning the path, and then we can add to the file scanner the file. Yep. All right. So the file name. Where is it here? Why don't I see that? Here. Okay, so we have this OpenGFX file, and then some asserts. Oh, and in the meantime, there was this struct tar header, which is probably how the tar files are organized. So I'm not an expert really about the tar files, but well, there's some name of the file and maybe some permissions. Check some size of the file inside the tar. And this one, so we have tar lists, which is just an array for. Okay, we have a map of tar file to tar directory, and we have as much as that as we have the number of subdirectories. Okay. So we just iterate. We have iterator of this. Oh, because we try to find the file name. Okay. Yeah, and probably since we have something, we'll just check that. And here we have the file handle. What's the file handle? Have we seen that? Okay, so it's just the fopen, or for Windows, it's just a different Windows function, which will just open the file and give us the file pointer. And here we use something that's called file handle, and this is some kind of type that will just help manage the file pointer of open file. It uses auto release. What is auto release? Oh, okay, it's unique pointer. In this case, it will just use some delete function and this deleter to just release the pointer via function. So in this case, this is fclose. Yep. So this will work this way, that after after this object is deleted, or in the course of deletion of this object, fclose will be called here on the pointer, which represents the file. So nice way to just automatically close the file if this file handle is destroyed. Okay. We return optional here, so obviously this has the value, and this f will be this file handle then with storing the pointer. So in the tar list of base set directory, we have this file name that we found, and then there is this file name base. Okay, there's simplify name. I accidentally skipped that, but I think it's just lowercase things. All right. So, and then we have some loop, and this loop just takes the pointer. No, sorry, it takes the tar header structure that we created, and it just reads as many bytes as this structure contains from the file. And we also see that it reads 500 bytes, which is probably the size of this header. Let's see. Is it? Yeah, it's exactly this, because this condition is passed. And then we have some position here that we update. I will probably keep it in the loop. And then th unused. So this is some 12 bytes. So I don't really know how this exactly works for tars, but this comment suggests that there are some old and new format issues. So probably it's just about this. Okay, and then there is some magic field again. It checks if this is the U-star, and probably this is also related to this. So probably not important here that much, at least for our basic case. The prefix contains the directory name. Okay, so prefix, right? So what I think is happening here is that we have the tar file, and tar file simply contains its own like packaged files and directories and maybe some hierarchy, and prefix just gives the information about the directory. And if it's empty, basically, so there's like array of characters, then we will skip that. So if it's empty, it's just a top level file. So we'll just extract string from this, which what I would guess is, yeah, we just create the span of the characters here, and then we just make valid. What is this make valid? Have we seen that already? Okay. Copies the valid UTF characters from string to the return string. Okay, so there's some conversion, and I just want to stop here a bit, because this is also very typical use, I think, of the string builder and consumer. So we'll just build a string of this builder object, depending on how this input string is constructed. So this consumer will simply analyze the input string, and we'll just add some context to the result via the builder. So it goes byte by one, and here it tries to write UTF until it's empty. And then, for example, yeah, so some control codes. Yeah, actually it matches. So what do we have here? So we have O, for example. And it's printable. I should check that. Okay, so it checks again some codes, and here it checks. Okay, so there are some special codes like sprite start, sprite end. Not really sure why, but anyway, in the end we just put UTF into string builder. So we try to encode this input, which it's actually already Unicode. Okay, what's that? Encode a character to UTF. Okay. So, all right. So if it's less than that, it just put as it is. There are also like other conditions. Okay. And this function is fetch n bits from x started at a bit. Okay, so it just converts some special characters to something that's probably displayable. And here, yeah, so this string builder contains some destination, which is just a string, and it just appends some data. So we should be just saying here that we see something. Yeah, okay, so O is appended. All right. And here it goes for any bytes left and so on. So in the end, we just have the result. All right. So this way, we just build the name. And in this case, we see the characters here. So we have OpenGFX as a directory or some kind of high level entry, which is actually interesting because I thought, well, maybe this is like we haven't seen the directory name. But yeah, okay, let it be. So, and then extract the string. So again, we also saw that it's the size of the file, okay, as a string. So yeah, so basically it just converts since we have the character arrays, we just want to work with strings. So here it is. And then we just parse integer, which is interesting because I think this is the base. Is it the base? Yeah. So the base is 8, which actually makes sense to use this function, or to have this function. Skip until character not in. So how does it work? Find characters not in. I think we have seen that, or maybe not. Yeah. So starting from this position, so position 0, find first not of characters, right? And then, okay. So let's get back. Okay, so we have all zeros, and we are looking white space and no new line. In characters until they are not. All right, so yeah, so there's nothing to skip really. So if all right, so it actually means that we'll just skip the white spaces, probably, which are at the very beginning, until we just find some number. And then we try to read integer base directly from the consumer. And then it will just pick the integer, which we have seen before, right? So if it happens to be, then we'll also skip integer base. Oh, okay, I see. So for example, here, let's see, this is consumer, so the source is like this. So I will assume for 8, we'll just skip until characters not in, 0, 1, 2, and so on. So if there's some base information, then maybe it will just be skipped, like here. 0x is skipped. Okay. And also, So the base is 8 here, but anyway 11, so it seems like we just read the whole string. And the result is like this, so we have like 10 base integer. And then there's probably nothing to skip, but just in case it will just check it, but well, it's just the end of string. So non-bytes are left. So we just return the result, and yeah, here it is. We have just an integer. Okay, so that was the size of the file which is inside the tar. And then there are some type flags. In this case, it's I think just 0 or 0 character actually. Character, yeah. Okay, checking name. Yeah, and 0 just means the regular file. We can have hard links, symbolic links, some subdirectories, apparently. Let's see, file name, skip position. So we just copy to the entry what we found. Tar file name, size of the file inside, and then at which position this was encoded. Simplify file name. Again, okay, so this just scans through all the characters and just makes the lower. So just lowercase. Let's see why it's doing this way. Simplify file names from tars. Force name to lowercase. Okay, so some logging messages, and then at the end, so we have our entry, and here it's inserted. So let's recall what it is. It's just the list, like tar file lists, or actually the array. So first we just for this subdirectory, the base subdirectory, we just take the tar file list, which is the map, and for this map we just put an entry. Okay, and the entry, so this will create the value types of the pair, the key value pair of entry, which is this thing, and the name will be the base, right? Let's see, so the tar file, and then we have separator, and then we have name, and that gives like the full entry path. And separator is also the slash. Okay. And if it didn't exist, I probably will just increase the counter here. Here it goes. And yeah, and we are done. Skip to the next block. Right. So we just have this check. And must power of 2, okay. Makes sense. And then the base of number we're searching, the smallest multiple of n equal or greater than x. Okay. Skip to the next block. Okay, it's a bit bigger than I expected, but probably it's because yeah, so we align this value, so it's now overridden, so I cannot show you what was before, but this gave us the size, like the real size of the file, but probably tar just aligns it to this amount of bytes. So we just have to make sure that we essentially skip the pointer in the file, not the real memory pointer, the location we scan the file at to the proper window, which is aligned to this value 512. And the global position. So we read this. So you remember we just read the header. So now we're skipping the content of the file. And then we just continue with reading any other files that are inside. So maybe something that would be worth just checking is this director thing. Let's make sure we don't exit from the function. Oh, okay, no directors here. Okay, so maybe I'll just leave the debugging point here. If we hit this sometime, then we'll just have a look. But basically what I see here is that this will be just the directory, and then we just fill it in like tar list, like here. Okay, so here's like tar file list, but there's also tar list. Okay. And then for this search directory, we also say, okay, so here's the directory that we just detected. Okay. So how many files are there? 10. Yeah, and we can see on the console. Maybe can I just make it bigger? Okay. So some grf files. These are asset files. And some metadata, some readme files. Okay. Yep. So this function returned the amount of files, I guess. No, it just checks if the tar files, the scanning was successful. Yeah, and if nothing was found, then the num was not increased. Okay, so there was one file, one tar file. The tars here, what was the tars? However, into the search into tars. Okay, yeah, this is some flag that probably allows you to just do some lookup inside the tar files. But we are looking for the tar files, so probably it's not the case. And then for base dir, I assume old GM, so probably we just run this scan with some other form of subdirectory, additionally this. Okay. So now this scanner just filled the structures and we know where the tar files are. This again allows to scanning for some old data directory. So I will just skip that. And at this point, the scanning of base set dir is done. And there are like lots of other directories to scan, but just depends on this modes. Let's see if I can check how these tests work. So we are in the base bit set. Okay, and there's one bit. I think this is this base dir mode bit set here. So we just check. Yeah, and we are asking about new grf, which is something different. So this new grf will just contain, it's probably mapped to some value. Let's see if I can check it here. Yeah, okay, so this is enum. So probably it's just the value 2. And then it just indicates that we need to just shift the bit left and have just logical end here, or the bitwise end actually, not logical. So this is bitwise end, and we just check if it matches. So very simple check in the end. All right, so I don't think anything interesting more will happen here. We just get in the end number of files that we scanned, and this is just, we just found one. And then we are out of tar scanner and back to the main routine. And what happens next is some dedicated server. So we're not in the server mode. If we are not, then maybe some dedicated forks, but not really. We must fork here or we'll end up without some resources. We need like sockets. All right. So single mode only for now. So I will not deep dive here. I don't know really what it is in a way. So, and next thing is loading from config. So maybe let's have a look. We have the flag that there's a startup. So I assume, so we have, so what have we done already? We scanned, we check which config paths are available, and in these paths we just look up for specific asset files, and specifically the tar files actually. So we found one in this particular case, and now there are also some config files that maybe can customize the game or actually save some options of the game. I'm not really sure. So for sure here, what happens is that there's some config ini file. What do we have here? Okay, it can be loaded from disk and then inherits from ini file. Nice. And this is actually the structure. Okay, and it holds quite a bit of things here, like some groups, comments, and so on and so on. And we have these global things that we set up earlier based on how we scan the configuration directories. So for example, this file. Okay. So I will try to, maybe let's open that. So maybe let's open that. Okay. Yeah, so traditionally the ini file just contains some groups and then key value pairs. And what I will expect here, it will just, this piece of code will just load this file, as name suggests as well, load from disk. The ini group is declared here. And so is the file opened. I think we have seen that. So we just read binary, file in the binary mode. It's interesting. Okay. Open file somewhere in the personal or global directory. Okay. Okay, subdir. All right. What's that? Yeah, type of the subdirectory. Okay, I forgot about it. Have we been here actually? I don't want to go through the same function again. But as I see, we have just opened the file and just got the file handle. And that's it. Okay, maybe let's keep that. I don't want to repeat something again that was already shown. So we have this optional thing which contains our file handle. So we'll just see how big the stream is. Okay, so this is the size of our file. And then what happens here is that we just get information to this buffer, so 1000 tops, and I think it just reads the one line to the buffer, so like this. Okay, so new line, zeros. Oh, what type is it? It's character. Okay, so probably yeah, so there's new line. I just don't understand. Okay, we'll consume that. Oh, right, okay. So obviously this line is empty here. So we read this fgets just read one line. So obviously everything else beyond index 1 here is garbage. So that's why I got confused by all this content here. So okay, line first empty line, not interesting. It somehow treats it as a comment, I guess. Okay, continues. Skip comments and empty lines. Yep, perfect. We just skip that. And then we have the second line, which actually contains our group. Here it's null line terminated and then null terminated for the string. So just this one. And then we have a consumer on top of this buffer. It's just that we have this stream view, which just trims the white spaces or new lines, which are prefixing and possibly suffixing. I'm not really sure. I think it's just prefix trim. And the group. Okay, why did it not trigger? So what's this condition about? So okay, group is null and the type. Okay, it's null, but then consumer anybody's left. Okay, yeah, because it does this for this empty line. And then we check for if it's a group. Read character if. What does it do? So it reads 1 byte. If what? If it matches this one. Oh yeah, because we are in consumer. So if we check if we are opening the group. So the group is this just the bracket. So we pick. We have seen pick, I guess. So we just compare this string at like at this position until yeah, just pick if why is it Yeah, this is like a string compare. All right, okay. Position and one compare. Yeah. So we just compare this position, this amount of bytes, so size of this string, with the string content we have here. Okay. And then if it's the same, then well, yeah, we pick that, it's this. And then for the result, we just skip. Yeah, so we just should be skipping that because like the opening bracket does not matter. Okay. So we know that the group starts and we just we just forward the pointer in the consumer. And then we'll just read until we have the closing bracket, right? So, yeah. There's also some separator usage. I'm not really sure this, but let's see. Treatment of separator characters. Read all separators. Okay. Yeah, so what to do with the spaces, I believe. Or some other characters that separate stuff, as the name suggests. So we'll just pick first for the string. So how is it implemented here? Okay, so we just take the string at this position. So we have this group name here. So I think it will be just without the bracket. And then we look up for the closing bracket. And if we found that here, so we have a look if there's like a, okay, keep separator. Right. Oh, yes, because then if we want to like read separators, then there's a different logic, but by default, we just take from buffer and just like trim this right bracket. So we will just get the group name in the end. And since this was on the peak, because well, maybe we were not successful, I think. So for that case, we just skip the result here. And then again, if there was a separator, then yeah, we would have some skip logic, but not for this case. Okay, so we have the group, and I think we are done with the consumer, right? So this file error would trigger if there will no closing bracket, I believe, or just the end of file. So once we have a group, we will just create the group here with this group name, and for this init file, it will just look up in the group names. Okay, so we have some group names here. This seems to be initialized already. Or not. List group names. Yeah. I'm not really sure where it was initialized. Maybe I just skipped that. Maybe here. Probably yes. But anyway, we use ranges to just look up the name of the group if it's already present. IGT variables. It's the type. So it was not found, or it was found. We look up here. Oh, we check against the end. So so it was not in either of these lists. So we just fill the groups. At this moment, it's just empty list. We just add the group as a type IGT. Okay, what's this shortcut about? Init group type, probably. So okay, so we just know that this is a variable and not the list or not the sequence, right? Because we may have a different configuration types and we just want to distinguish. Fine. And then we have a comment, and the comment was set here earlier. I don't think it matters that much, but it's still set. And then we clear that. Okay, because the comment was for the line. Okay, and then we just move on line by line. Probably nothing super exciting, though. We can check just like how the values are parsed. So we already have a group created, and then under this group we can just check what's the type. So okay, it's not a sequence. Why the group has the type could have the type of sequence? I'm not really sure. Okay, and then when we read from the consumer the character, but only if it's what? If it's okay, double quote. Okay. So it's false, so probably there is no quoting. And then we have some key separators, right? So if we have a look at this config file, where was it? Where did I have that? Yeah, so we just have such structure, like here. So the separator is equal sign in this particular case. So we just find where's the next character, and we just read these many bytes. All right. So we just pick again. If end of file, then probably there's some problem to report. And then we just skip and we just return the result, which is display opt. That's correct. That's correct. And then we create item of this particular key, and the init group that we have just working with have the list of these items. You see it's here. And then each item will just have a name, just how we read, and then the optional value and probably the comment. Okay. So we just fill it with the name. And then the comment is just the comment that we saw earlier, it's just that it's empty now. And then we just skip until parameter separators. Okay, because I'm not really sure where we are in the position, but I assume that we just read the key and then we need to get past this equal sign and just get into the value. So, okay, so no double quote as we have seen, and it's not empty. Okay, and then we just have the get left data from the consumer. Okay. So just the substring of what is left from the current position. Yes. So we should see this thing, and then make valid, which we already seen. Okay. We skipped into here, but we still have the item, right? We still have the item. Or don't we? Oh, we created it in the group. So we should have the item here, and then, yeah, and here it is. Yep, so the full string. So that is correct. So what happens is that we created the item, and then we obtain the reference, and we just split up the item with some values in the group. Okay, so it goes on and on. So probably, well, we're not gonna go through each item. Just worth mentioning is that we have groups here. Okay, group 0, and then it has all these items like display out, full screen, and so on and so on. And there are different groups, and we just scan the file this way. And this was what happens in the constructor. Oh, and probably here, this was what I skipped, and there was like the base constructor invocation that just filled these group names, some defaults. All right, so there are more files here. So for each we get ini file, and then there's quite a bit still to be loaded, I believe, but maybe that's something that I will talk about next time. And for today, well, we have seen how the tar files are scanned and a bit about these configuration files. So while maybe it's not the most exciting part of how the game is being designed and how it runs, but it's probably essential to just understand how the assets and all the options get in to our running program, and we'll get to our interesting stuff as well soon, I believe. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.